Thank you for tuning in. Welcome to Ascending Grades. This is Maranda High School, a post-mock. We are in the final journey for the physics paper 2. I'm going to do a presentation of section A. Therefore, we can go hand in hand and we find our section A. So, here is the paper. You're told in the first question that you need to explain using the domain theory. Explain how strong heating causes the magnetization. How strong heating causes the magnetization. This one is just a method of doing the magnetization. The moment you use heating, then strong heating causes the magnetization because it disrupts the ordered alignment alignment of magnetic domains causing them to break up and orient randomly. So remember, if a material is magnetized, then these uh, domains or the dipoles will align themselves in a specific direction. But when they are disoriented, then the magnetization starts occurring, taking place, and then they will arrange themselves just randomly. Question 2, you're told that you are provided with two identical cells, two lamps, and a switch. Then you are told to draw a diagram, a circuit diagram that would ensure the bulbs have maximum brightness. The first thing that we need to do for us to have maximum brightness, then we need to ask ourselves, how are we going to arrange the cells? So for the cells, must be connected in series. Why? So that the voltage to add up. So the first step is to make sure that the cells are in series. So I'm going to draw them. These are now my two cells. Then the second thing is the arrangement of the lamps. We want each lamp to have the same potential difference across it. So the lamps must be connected in parallel. So I'm going to draw my lamps. The first one and the second one. And then make sure that all of them are in parallel. Then remember we are supposed to give a place for the switch. So that becomes my switch. Avoid using freehands. So these are the cells and these are the lamps. So why do we avoid the cells being in parallel? Because the voltage will be very low. Again, if we use the lamps in series, then we are going to increase the effective resistance of the system. We're going to increase the effective resistance of the system. Then you're told, state one and disadvantage of using such arrangement in A above to light a whole house with many bulbs. Remember, if you are using cells, we are not talking of electricity, but we are talking of either this one being from a battery, which we are just trying to mean from cells. So the disadvantage is that when you're using the bulbs in parallel, using many bulbs in parallel, it drains the cells very fast. That is the first disadvantage. And what will it be happening in return? So in return, this one is going to reduce and reduce the brightness of the bulbs of all the bulbs. You're given this question here. Question 4. You're told that the operating current when a heating element is rated at 3 kilowatts and 240 volts mains. So we know that our power is 3 kilowatts, which is equivalent to 3,000 watts. Then our potential difference is 240 volts. Then you are being asked about the current. So from power is given by VI, then you can substitute and say that 3,000 will be given by 240 times the current. Making the current the subject the formula, you will get 3,000 divided by 240, and this one will drive you to a current of 12.5 amperes. 12.5 amperes. Explain how polarization affects the working of a single cell. So polarization is the production or the release of the hydrogen. Then hydrogen gas forms hydrogen gas acts as an insulator, or we can just say is a poor conductor. And this increases the resistance to the flow of current. We have our next part. Where we are having a question on the reflection on plane surfaces and the formation of images. The figure shows an object O placed in front of a plane mirror. Then we are told use a ray diagram to locate the position of the image. The first thing that you need to understand is what's the properties of the of the image forms. One, initial distance must be equal to the image distance. Then the size of the object must be equal to the size of the image. Using this, then you can first trace where it is going to be located. So I'm going to use my ruler here. So from the midpoint of these objects up to the surface of the mirror, I'm getting a distance of 3.3. Therefore, I'm supposed to also make a distance of 3.3 towards or behind the mirror. 3.3. So this is where I'm going to form my image. And for you to be more accurate, then you can make a line like this so that you can see where it is going to be formed. So my image is formed at this point. So I'll draw it dotted like that. Remember, this line is just to aid you to locate the position of the image using U is equals to V and using HO is equals to HI. Then we are going to delete it. We are going to remove it because just an aid. Then from there, we shall look at the reflected rays, from the image, to the eye. So, here's what I'm going to do. I'll draw just two rays. from the image like this. And then another one like this. So these two rays are just reflected rays. Then now, from the laws of reflection, if you draw the normal rays here, the normal rays, then you'll be able to locate the incident rays from the object. So these are, I'm going to trace it. That is the first ray, incident ray. And my second incident ray will be like that. Like that. So ensure you show the ray direction for you to be awarded 2 marks. Then now we can move to our next question. A coin is placed at the bottom of a beaker filled with water to a height of 2.4 centimeters as shown. Then you're told, given that the refractive index of water is 1.33, determine the apparent depth of the coin. We know that using the real depth and apparent depth, refractive index is given by the real depth over the apparent depth. Therefore, 1.33 will be given by the height of 2.4 divided by the apparent depth AD. So, making AD the subject of the formula, then it will be 2.4 divided by 1.33, and this will lead us to a figure of 1.8 centimeters. A figure of 1.8 centimeters. Allow me to confirm that working. Okay, I've confirmed the working is okay. Then we have question 7, which reads, in the circuit diagram shown, the voltmeter reads 4 volts. So this one reads 4 volts. We have 2 resistors which are connected in a series, each of 10 ohms. Then we have a connected ammeter. Then you are told determine the reading of the ammeter. So I'm going to use from the Ohm's law, V is equals to IR. Then my 4 volts will be the same as the current that is passing through the 10 ohm times its resistance. So my I will be 4 divided by 10, you get 0.4 amperes. So this is what is correct. In case, just some explanation, the current that is passing through the 10 ohm and this 10 ohm is just the same. So if we calculate using just one part of the resistor, then we still get 0.4. But in case you are asked about the EMF, we know that the potential difference across the resistors, each will carry its own potential difference. So also Since they are of the same size, also the voltmeter reading here will also be 4 volts. So the EMF will be 4 plus 4 getting 8 volts. That will become the EMF. That is just an explanation in case of. Question 8. We are told that we are having a chart showing arrangement of different parts of electromagnetic spectrum. Then we have radio waves, A, infrared, visible, B, X-rays, gamma rays. Then you are told name the radiation represented by B. This one is the ultraviolet, one you call UV radiation. And A will be microwave. So you ask about yourself because question B of it is referring or it is relying on what is the meaning of A. So you are asked, them a device that can be used to detect radiation A. What is radiation A? This is a microwave. And this one is tested by use of dry crystal detectors. And we still have solid state diodes. Solid state diodes. Now we have the last parts of section A, sorry. You are told that Kcse 100 FM broadcasts at a frequency of 100 Hz. If the velocity of the radio waves is 3.0 times 10 raised to power 8 meters per second, then you are told determine the wavelength of the waves. I'll give a working in 2 ways here. Number 1, as per the question. Number 2, we change the question. So in this case, you are told that our frequency is 100 Hz. And then our velocity is 3.0 times 10 raised to power 8 meters per second. Then our lambda will be what? So from V is equals to F lambda, then my 3.0 times 10 raised to power 8 will be given by 100 times 100 times lambda. That is what we are looking for. So my lambda will be 3.0 times 10 raised to power 8 divided by 100, and you arrive at 3 million meters. And 3 million means 3.0 times 10 raised to power 8. We have case 2. If we try to alter the question, because you can see this frequency is too low. If we say now this one becomes a frequency of 100 millihertz, then we maintain the speed to be 3.0 times 10 raised to power 8. Then our lambda will be what? So this becomes a velocity. So it will be, our lambda will be the same as 3. Sorry, kidogo. So this one, if you convert it into hertz, then it will be 100 times 10 raised to power 6 hertz. So this becomes 3 times 10 raised to power 8 divided by 100 times 10 raised to power 6, giving you 3 meters. This is just in case the question is changed. We have question 10. The refractive index of turpentine is 1.47. What is the refractive index of air with? So we first say the refractive index of turpentine with respect to air is 1.47. Then now the question is asking us the refractive index of air with respect to turpentine. This will be the same as the inverse of this. And this becomes 1 over 1.47, leading us to 0.68. This is our last question, 11 and 12 of parts. Section A. So you are told that uranium-234 undergoes radioactive decay, or is represented by the equation shown. Then you are told define the value of A and B. So in this case, we start with the B, part of B. So you can see from this equation, we are producing 2 alpha particles. So we need to write the equation and say that the 234 uranium will be, let's use this one, is given by B of X, A of X plus 2 alpha particles, which is represented by helium. So 4, 2, He. So taking the upper part, the mass numbers, 234 will be the same as B plus 2 times 4. So this becomes 8. So my B becomes 234 minus 8. And this comes to 226. Then for the second case, for the mass numbers, 92 will be given by A plus 2 times 2. 2 times 2, this is 4. So my A will be 92 minus 4, becoming 88. And therefore, A is 88, B is 226. Like that. State of factors that affect the strength of an electromagnet. We still have question 13, sorry. So this one, we have the number of turns. The number of turns, the amount of currents, and we have the length of the electromagnets. The length and also the shape of electromagnets. We have our last question. A material of resistivity of 1.0 times 10 raised to power negative 6 ohm meter has a cross-sectional area of 4.5 times 10 raised to power negative 2 millimeters squared and length of 90 centimeters. Determine its resistance. So, you analyze the question. The resistivity is 1.0 times 10 raised to power negative 6. Our cross-sectional area is 4.5 times 10 raised to power 2 millimeters squared. And this one in SI units, you just need to divide by 1 million, or you multiply by 10 raised to power negative 6. So it is 4.5 times 10 raised to power negative 2 times 10 raised to power negative 6, which gives me 4.5 times 10 raised to power negative 8 square meters. Then we have our length of 90 centimeters. In SI unit, it becomes 0.9 meters. Then resistance is given by resistivity times length over area. And therefore, substituting, R will be given by 1 times 10 raised to power negative 6 times length of 0.9 divided by 4.5 times 10 raised to power negative 8 meters. And from computation, we are supposed to be getting 19.6 ohms. Thank you so much. All best wishes from Ascending Gates.